Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video distinguishes the exact method of hypothesis testing, which uses the binomial distribution, from the approximate method. Let's get started. So, the methodology that we've looked at so far for hypothesis testing uses the normal distribution as an approximation to the binomial distribution. The exact method then just gets rid of the approximation. We're going to bypass the normal distribution and go directly to the binomial distribution for our hypothesis testing. So because we're not approximating the binomial distribution, we don't need to check to see if we have at least 5 failures and at least 5 successes. Okay, because this was an assumption that we made because we were approximating the binomial distribution. We're not approximating anymore when we use the exact method, and therefore it doesn't matter what those values of successes and failures are. We can use the binomial distribution to resolve our hypothesis test. And this is how we do it. So for a left-tailed test, the p-value is going to be the probability of getting X or fewer successes among n trials. For a right-tailed test, the p-value is going to be the probability of getting X or more successes among n trials. And then for a two-tailed test, you've got to compare the sample proportion with the claimed population proportion. So if the sample is greater than the claimed population proportion, then the p-value is going to be twice the probability of getting X or more successes. If, however, the sample is less than the population, then the p-value is going to be twice the probability of getting X or fewer successes. Let's go back and look at our XORT gender selection example to illustrate how this works. So we're testing the method of gender selection, and now we've got, after we did the whole initial 100 couple thing, now we've got 10 randomly selected couples that are treated with a new and improved method. And 9 of the babies turn out to be girls. So 9 out of 10 is a lot better than what we had previously. So maybe it is new and improved. But who knows? 10 is kind of a small number for sample size. So maybe not. Anywho, our alpha is 5%. We're using that to test the claim that with this new and improved method, the probability of having a baby girl is greater than 75%. So first we identify our null and alternative hypotheses. So the null hypothesis, always a statement of equality. So the proportion is going to be equal to 75%. And then the claim itself is that it's greater than 75%. That has no semblance of equality to it, so we can just adopt that claim as our alternative hypothesis. So we're looking at a right-tailed test here. We know it's a right-tailed test because we look at that inequality sign in the alternative hypothesis. So here this is like an arrow pointing to the right, so it's a one-tailed test that's on the right. That means the p-value is going to be the probability of getting 9 or more successes among n trials. Because we've got 9 of the babies that are girls, and we've got 10 total. So 9 out of 10 trials were actually successful. And it's going to be more than because we've got that right-tailed test that was indicated in our alternative hypothesis. And we're just going to take 75% as the actual probability of success, because that comes from that's the claimed value itself. So with that in mind, we can go into StatCrunch, get our binomial calculator out, put in the values that you see here. So we get the 10 trials, probably success 75%. We want greater than or equal to 9. And that comes out with a certain probability here. That's the area under the discrete curve that you see there. So 0.244, that's our p-value. And now we got the p-value, so now we can compare this with our significance level of alpha. And when we do that, we see that, yes, our p-value is bigger than our significance level, so that area of the p-value cannot fit into the area that is the rejection region. Therefore, we're outside the region of rejection, and we fail to reject H0. And then, of course, from there, we just carry it through to share our conclusion. We fail to reject H0, so there's not sufficient evidence, and it's going to say to support the claim because we have a one-tailed test. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.